The reaction rate is greatest at the beginning and it slowly decreases. Which gases have got a big enough relative molecular mass for this method to work? Well, you need gases with a relative molecular mass of 20 and above, really. So we're talking about, the classics are carbon dioxide. You could do it with sulfur dioxide. You could do it with oxygen, which is a relative molecular mass of 16 plus 16, 32. But which gas definitely wouldn't work? And you guessed it, it's hydrogen. Hydrogen's got a relative molecular mass of 2 because it's got 2 hydrogens per molecule and its mass is too small. So the decrease in mass on the balance as hydrogen is given off, well, to 2 decimal places, it doesn't give you good enough readings, so it doesn't really work very well. There's too much, as we call it, uncertainty, so there's too much error involved. Okay, that's method 2. Method 2 is loss of mass. Method 3 is when there's a color or some kind of precipitate formed or even used up in these reactions. So one of the reactants or products is colored, and we can use devices called colorimeters that can measure the intensity of the color, and they can show us how the reaction rate changes over time. We can also time how long it takes for a precipitate to be produced or for something to be obscured. And the classic reaction here is a reaction between sodium thiosulfate and hydrochloric acid. They produce a yellow precipitate. It's actually a precipitate of sulfur, and the cross disappears with time. So you can play around with the reaction and you can measure how long it takes for the cross to disappear. Now you'll do this when we get back to school. This is one of the classic reaction rate experiments. So we'll go back and we'll do these experiments when we get back. Okay? So it's a good idea now for you to see that, because just me talking about it's not really a brilliant idea. So go and watch this video and then we'll continue. So pause me now. Okay, I'm going to continue. The other kind of reaction here is a reaction that produces a color, and the iodine clock reaction is another case. So in this case, the reaction produces a black color when it's complete. And you can time it. It's pretty quick. So you can time how long it takes for the black color to appear, and that gives you an idea of the reaction rate. The faster the reaction, the quicker the color appears. Good idea now is to just stop this video and watch the video on YouTube for this reaction. Right, that's a good time also for you to open your exercise books, read the pages indicated and do the questions. So pause me again, do the questions. The answers to the questions I'll put on the website or on Google Classroom, so that once you finish all of these questions from this section, you can check your answers.